Euclid Maths, Euclid Maths, Euclid Maths.
Hi everyone, welcome to 8th part of our lecture series on vector differentiation. In this part, we are going to learn Laplacian operator, solenoidal vector and a few problems on these concepts. Thanks for your feedback. Enjoy the lecture.
Now, let us see a new vector differential operator. This new vector differential operator is called the Laplace operator or the Laplacian operator. It is denoted by del square. If phi is a scalar field, then del square phi equals del dot of del phi. It is also denoted by div of grad phi. It is defined by del square phi equals dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. This operator is called the Laplace operator. If we equate this del square phi to 0, that is, if dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square equals 0, we get a partial differential equation. This partial differential equation, dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square equals 0, or del square phi equals 0 is called the Laplace equation. Let us take one example. Choose a scalar field phi from R3 to R, which is defined by phi of x comma y comma z equals xy plus yz plus zx. For this function, we can find del phi. What is the gradient of phi? Del phi equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. So, we have to first find out dou phi by dou x, dou phi by dou y and dou phi by dou z. Here in this example, dou phi by dou x equals y plus z, dou phi by dou y equals x plus z, and dou phi by dou z equals x plus y. Now, let us find out del square phi. Del square phi means div of grad phi. Grad phi is del phi, which equals I cap y plus z plus j cap x plus z plus k cap x plus y. For this function, the component functions are phi1 equals y plus z, phi2 equals x plus z, phi3 equals x plus y. So div of this grad phi equals dou phi1 by dou x plus dou phi2 by dou y plus dou phi3 by dou z. In other words, del square phi equals dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. If we plug in all these values, we get del square phi equals 0. Here comes the case div f equals 0. A vector field f from R3 to R3 is said to be a solenoidal vector field if its divergence is 0. So, a solenoidal vector field is a vector field whose divergence is 0. If f maps R3 to R3 is defined by f of x comma y comma z equals y square z I cap plus z square j cap plus xy k cap. Then its component functions are f1 of x comma y comma z equals y square z, f2 of x comma y comma z equals z square, and f3 of x comma y comma z equals xy. If we find dou f1 by dou x, it is 0. Similarly, dou f2 by dou y and dou f3 by dou z equals 0. Hence, the divergence of this vector field is div f equals 0. So, in this example, f of x comma y comma z equals y square z I cap plus z square j cap plus xy k cap. It is solenoidal because its divergence is 0. If I take our velocity vector r cap equals xi cap plus yj cap plus jk cap, we have seen already its divergence is div r cap equals 3. That means div r cap is not equal to 0. So this velocity vector r cap is not a solenoidal vector. Solenoidal means it looks like an electrical coil. So a vector field is said to be a solenoidal vector field if its divergence is 0. Let's take a few problems on the concepts which we have learned so far. As a first problem, let us consider a vector field v of x comma y comma z equals xi cap minus yj cap plus z square k cap. In this problem, we need to find out the divergence of v at the given point, say p equals 3 comma minus 1 comma 4. Let's consider the given vector field v of x comma y comma z equals xi cap minus yj cap plus z square k cap. Whenever we have a vector field, we need to write down its component functions. In this example, the component functions are v1 of x comma y comma z equals x, v2 of x comma y comma z equals minus y, and v3 of x comma y comma z equals z square. We compute the three pieces dou v1 by dou x, dou v2 by dou y, and dou v3 by dou z to find out the divergence. In this example, dou v1 by dou x equals the partial derivative of x with respect to x, which equals 1. Dou v2 by dou y equals the partial derivative of minus y with respect to y, which equals minus 1. Dou v3 by dou z equals 2z. The divergence of the given vector field v is given by div v or del dot v equals dou v1 by dou x plus dou v2 by dou y plus dou v3 by dou z, which equals 1 plus minus 1 plus 2z. It equals 2z. So the divergence of the given vector field v equals 2z. But we have to find out the divergence at a given point, say p equals 3 comma minus 1 comma 4. Here x value is 3, y value is minus 1, z value is 4. So in the divergence of v, we have to substitute these values. Since div v equals 2z and the value of z is 4, we obtain div v equals 8. We are done. This problem 2 is also a similar problem. In this problem 2, we consider a vector field, say U. We need to find out its divergence at a given point. Consider the given vector field U of x comma y comma z equals xy square I cap plus 2x square yz j cap minus 3yz square k cap. Let the given point be capital P equals 1 comma minus 1 comma 1. To find out the divergence of the given vector field, we need to write down its component functions first. In this example, the component functions are u1 equals xy square, u2 equals 2x square yz, and u3 equals minus 3yz square. We have to find out the partial derivatives dou u1 by dou x, dou u2 by dou y, and dou u3 by dou z to find out the divergence of u. The divergence of u is given by div u equals del dot u equals dou u1 by dou x plus dou u2 by dou y plus dou u3 by dou z. Let's compute these three pieces, dou u1 by dou x, dou u2 by dou y, and dou u3 by dou z. First, dou u1 by dou x equals y square. It is the partial derivative of u1 equals xy square with respect to x. Dou u2 by dou y equals 2x square z, and dou u3 by dou z equals minus 6yz. Div u equals the sum of all these three pieces. That means div u equals dou u1 by dou x plus dou u2 by dou y plus dou u3 by dou z, which equals y square plus 2x square z minus 6yz. Now we found the divergence of u, but we need to find out this divergence at the given point, say P equals 1 comma minus 1 comma 1. So we need to substitute x equals 1, y equals minus 1, and z equals 1 in div u. If we substitute these values, div u equals 1 plus 2 plus 6, which equals 9. So the divergence of the given vector field u of x comma y comma z in this problem at the given point P 1 comma minus 1 comma 1 is 9. This is a very simple problem. In problem 3, the given function is phi from R3 to R. So it's a scalar field. We want to find out the divergence of grad phi. That means we have to first find out grad phi, and then we need to compute the divergence of the gradient of phi. Suppose phi is a scalar field on R3. Let's see what is its gradient. The del phi or grad phi equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. We have already observed one point. If we apply the gradient operator on a scalar field like phi, we obtain a vector field grad phi equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. For this vector field, we have to find out the divergence now. In this vector field grad v, the first component is dou phi by dou x. The second component function is dou phi by dou y. The third component function is dou phi by dou z. To find out the divergence, we need these component functions. Now, the divergence of this vector field grad v is div of grad v, which again equals del dot of del phi in symbols. This is equal to the divergence of the vector field I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. It is the sum of the three pieces, the partial derivative of the first component with respect to x plus the partial derivative of the second component with respect to y plus the partial derivative of the third component with respect to z. Here, dou by dou x of dou phi by dou x plus dou by dou y of dou phi by dou y plus dou by dou z of dou phi by dou z becomes the divergence of grad v. That again equals dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. Hence, the divergence of grad v equals dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. As we have seen previously that this is equal to the Laplacian operator del square phi. Hence, div of grad v equals del square phi. We are done. Problem 4. In this problem, a scalar field f is given and it is given that this vector field is a solenoidal vector field. But in this vector field, somewhere P is given. If this vector field is solenoidal, we have to find out the value of that constant P. Let us solve this problem. Suppose that the given vector field is f of x comma y comma z equals x plus 3y times I cap plus y minus 2z times j cap plus x plus pz times k cap. Given that this vector field is solenoidal, what is the meaning of a solenoidal vector field? A solenoidal vector field is a vector field whose divergence is 0. Since the given vector field is solenoidal, we have to equate its divergence to 0 and we need to find out the value of P. First, let us find out the divergence of the given vector field f. For this function, the component functions are f1 equals x plus 3y, f2 equals y minus 2z, f3 equals x plus pz. For these functions, let us find out dou f1 by dou x, dou f2 by dou y and dou f3 by dou z. Since the first component function is f1 of x comma y comma z equals x plus 3y, its partial derivative with respect to x, that is dou f1 by dou x equals 1. Since f2 of x comma y comma z equals y minus 2z, its partial derivative with respect to y, dou f2 by dou y is also 1. Since f3 equals x plus pz, dou f3 by dou z equals p. Now, the divergence of f is the sum of these three component pieces. So dou f equals dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So dou f equals 1 plus 1 plus p. It equals p plus 2. But our given vector field is solenoidal. So its divergence is 0. If we equate dou f equals 0, we obtain p plus 2 equals 0. From this, the p value is minus 2. So the given vector field becomes solenoidal whenever p equals minus 2. Problem 5. In this problem, phi is a scalar field defined on R3. It's given that this scalar field satisfies the Laplacian equation. Then we need to prove that its gradient is a solenoidal vector field. Let's prove this problem. Consider a scalar field phi from R3 to R. Given that it satisfies the Laplace equation. What is a Laplace equation? We have seen it before. Laplacian equation means dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square equals 0. In other words, del square phi equals 0. In problem 3, we have observed that del square phi can be written as div of grad phi. So div grad phi and del square phi both are same. The Laplace equation says that del square phi equals 0. On the left hand side, instead of del square phi, let us substitute div of grad phi. Then our Laplace equation del square phi equals 0 becomes div of grad phi equals 0. Here, if we observe the divergence of the del phi or gradient of phi is 0. Gradient phi is a vector field. In this problem, its divergent became 0. If the divergence of a vector field becomes 0, that vector field is called a solenoidal vector field. Since the divergence of grad phi is 0, we can say grad phi is solenoidal. But we have to remember the given condition that the scalar field phi satisfies the Laplace equation. So, grad phi is a solenoidal vector field provided phi satisfies Laplacian equation. We are done. Problem number 6. In this problem, a vector field f of x comma y comma z equals y square minus z square plus 3yz minus 2x I cap plus 3xz plus 2xy j cap plus 3xy minus 2xz plus 2z k cap is given. We have to show that this vector field is solenoidal. To prove that this function is solenoidal, we have to show that its divergence is 0. So let us find out the divergence of the given vector field. The given vector field is f of x comma y comma z equals y square minus z square plus 3yz minus 2x I cap plus 3xz plus 2xy j cap plus 3xy minus 2xz plus 2z k cap. For this function, the component functions are f1 of x comma y comma z equals y square minus z square plus 3yz minus 2x. For this component function, dou f1 by dou x is equal to -2. If we partially differentiate f1 with respect to x, we get -2 only, because all the remaining terms in this function don't involve x. If we take dou f2 by dou y, we get 2x, because f2 of x comma y comma z equals 3xz plus 2xy. If we find out the third partial derivative, dou f3 by dou z, we get -2x plus 2. To find out the divergence of the given vector field, we have to add these three pieces: dou f1 by dou x, dou f2 by dou y, and dou f3 by dou z. So, divergence of f equals dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. That equals -2 plus 2x minus 2x plus 2. That equals 0. So div f equals 0. So this vector field is solenoidal. We are done. Let us take the next problem. Problem number 7. In this problem, consider the velocity vector r cap equals xi cap plus yj cap plus zk cap. In this problem, we need to find out the divergence of r cap by r cube. Here, the given vector field is r cap equals xi cap plus yj cap plus zk cap. We have seen this vector many times. If we want r square, we need to find out r cap dot r cap. So r cap dot r cap gives us xi cap plus yj cap plus zk cap dotted with xi cap plus yj cap plus zk cap. So r square equals x square plus y square plus z square. From this we can find out the value of r. Small r is square root over x square plus y square plus z square. This is nothing but the length of r cap or norm r cap. If r cap equals xi cap plus yj cap plus zk cap, then norm r cap equals square root upon x square plus y square plus z square, which equals r. So r and norm r cap both are same. So small r is a scalar field. R square is also a scalar field, but r cap is a vector field. Now we require to find out r cube. R cube means root over x square plus y square plus z square whole cube. It equals x square plus y square plus z square whole to the power of 3 by 2. So r cap upon r cube equals xi cap plus yj cap plus zk cap upon x square plus y square plus z square whole power 3 by 2. This again becomes r cap by r cube equals x by x square plus y square plus z square whole power 3 by 2 I cap plus y by x square plus y square plus z square power 3 by 2 j cap plus z by x square plus y square plus z square power 3 by 2 k cap. Suppose that f of x comma y comma z equals r cap upon r cube. I would like to insist one point here. This vector field f of x comma y comma z equals r cap upon r cube has so much of importance in electrical engineering. Actually, this vector field r cap upon r cube represents an electric field from point charge. We have already found this vector field f of x comma y comma z equals r cap upon r cube. So f of x comma y comma z equals x upon x square plus y square plus z square whole power 3 by 2 I cap plus y upon x square plus y square plus z square whole power 3 by 2 j cap plus z upon x square plus y square plus z square whole power 3 by 2 k cap. We want to find out the divergence of this vector field. So we need to write down its component functions f1, f2 and f3. For this function, f1 equals x upon x square plus y square plus z square whole power 3 by 2. Look at the denominator. What is the denominator of f1 equals x by x square plus y square plus z square whole power 3 by 2. The denominator of f1 is x square plus y square plus z square whole power 3 by 2. It can also be written as r cube. So we can write f1 equals x by r cube. Similarly, f2 equals y by x square plus y square plus z square whole power 3 by 2. We can replace the denominator of f2 with r cube. So f2 equals y by r cube. Similarly, f3 equals z by x square plus y square plus z square whole power 3 by 2. If we replace the denominator of f3 with r cube, it can also be written as f3 equals z by r cube. Now, we need to find out their partial derivatives dou f1 by dou x, dou f2 by dou y and dou f3 by dou z. In this case, dou f1 by dou x equals dou by dou x of x upon x square plus y square plus z square whole power 3 by 2 or dou by dou x of x by r cube. If we find out this value by using the quotient formula in the differentiation, we get dou f1 by dou x equals r cube minus 3rx square upon r cube. Similarly, dou f2 by dou y equals dou by dou y of y upon x square plus y square plus z square whole power 3 by 2 or dou by dou y of y by r cube. Then dou by dou y of f2 equals r cube minus 3ry square upon r cube. Similarly, dou f3 by dou z equals r cube minus 3rz square upon r cube. Now we want the divergence of f. Div f equals the divergence of r cap by r cube equals the sum of the three pieces dou f1 by dou x, dou f2 by dou y and dou f3 by dou z. So div f equals dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. To find out the divergence of the given vector field f equals r cap upon r cube, we have to substitute the values of dou f1 by dou x, dou f2 by dou y and dou f3 by dou z. So div f equals dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Let us plug in the values of these partial derivatives. Then div f equals r cube minus 3r x square upon r cube plus r cube minus 3r y square upon r cube plus r cube minus 3r z square upon r cube. So div f equals the sum of these three, it gives us div equals 3r cube minus 3r times x square plus y square plus z square upon r cube. Here, the value of x square plus y square plus z square is r square. If we substitute x square plus y square plus z square equals r square, here we get div equals 3r cube minus 3r times r square upon r cube, that equals 3r cube minus 3r cube upon r cube, it equals 0. So the divergence of r cap upon r cube equals 0. If the divergence of a vector field is 0, we know that the vector field is called a solenoidal vector field. In this problem, the divergence of r cap upon r cube is 0. So the vector field r cap upon r cube is a solenoidal vector field. So we are done. In this problem, we have to find out the divergence of a vector field r power n r cap. This problem has two parts. The first part is we need to find out the divergence of r power n r cap. The second part is we have to find out the value of n under the condition that this vector field is a solenoidal vector field. Let us solve the first part. In the first part, let us consider the vector r cap equals xi cap plus yj cap plus zk cap. As usual, we find out r square. R square equals r cap dotted with r cap. So if we find out this r square, it equals xi cap plus yj cap plus zk cap dotted with xi cap plus yj cap plus zk cap again, which implies r square equals x square plus y square plus z square. R square is a scalar field. R is also a scalar field. R power n is also a scalar field. But r power n r cap is a vector field. To find out the divergence, we want vector fields. In this problem, to find out the divergence of r power n r cap, we first find out the partial derivatives of r. That means we find out dou r by dou x, dou r by dou y, dou r by dou z. To get the values of these partial derivatives, we take r square equals x square plus y square plus z square. If we partially differentiate this with respect to x on both sides, we get 2r dou r by dou x equals 2x. After cancelling 2 on both sides, if we find out dou r by dou x, it equals x by r. Similarly, if we find out dou r by dou y, it equals y by r. Dou r by dou z equals z by r. Next, we write r power n r cap explicitly. Since r cap equals xi cap plus yj cap plus zk cap, we get r power n r cap equals r power n times xi cap plus yj cap plus zk cap. Hence, r power n r cap equals r power n xi cap plus r power n y j cap plus r power n z k cap. We obtained a vector field r power n r cap. As soon as we have a vector field, we need to write its component functions. To do this, let us suppose that f of x comma y comma z equals this vector field r power n r cap. So f of x comma y comma z equals r power n r cap equals r power n x I cap plus r power n y j cap plus r power n z k cap. For this function, the component functions are given by f1 of x comma y comma z equals r power n x, f2 of x comma y comma z equals r power n y. Similarly, f3 of x comma y comma z equals r power n z. For these component functions, we have to find out dou f1 by dou x, dou f2 by dou y, and dou f3 by dou z. Let us first find out the partial derivative of f1 with respect to x. Dou f1 by dou x, which equals dou by dou x of r power n x. Here we have to use the product formula in differentiation. So dou f1 by dou x equals dou by dou x of r power n x equals r power n dou by dou x of x plus x dou by dou x of r power n. This equals r power n plus x n r to the power of n minus 1 dou r by dou x. Here we have to substitute the value of dou r by dou x. Then dou f1 by dou x becomes r power n plus x n r power n minus 1 x by r. This implies dou f1 by dou x equals r power n plus x n r power n minus 1 x by r. It again equals r power n plus x square n r power n minus 2. Dou f2 by dou y equals dou by dou y of y r power n. If we use the product formula of differentiation, dou f2 by dou y equals dou by dou y of y r power n equals r power n plus y n r power n minus 1 dou r by dou y. If we plug in the value of dou r by dou y equals y by r, here we get dou f2 by dou y equals r power n plus y n r power n minus 1 y by r, which equals r power n plus y square n r power n minus 2. Similarly, dou f3 by dou z equals dou by dou z of z r power n, that equals r power n plus z dou by dou z of r power n, which equals r power n plus z n r power n minus 1 dou r by dou z. If we substitute the value of dou r by dou z, we get dou f3 by dou z equals r power n plus z square n r power n minus 2. To find out the divergence of f, we have to add dou f1 by dou x, dou f2 by dou y, and dou f3 by dou z. So div f equals dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z, which equals r power n plus x square n r power n minus 2 plus r power n plus y square n r power n minus 2 plus r power n plus z square n r power n minus 2, which equals 3r power n plus nr power n minus 2 times x square plus y square plus z square. If we plug in the value of x square plus y square plus z square, here we get derivative equals 3r power n plus n r power n minus 2 times r square, because x square plus y square plus z square equals r square. As a whole, we get derivative equals 3r power n plus nr power n. If we take out r power n on the RHS, we get r power n times n plus 3. So, derivative equals n plus 3 times r power n. This is the divergence of the given vector field r power n r cap. So far, we have completed the first part of our problem, finding the divergence of the given vector field r power n r cap. The next part of this problem is we have to find out the value of n under the condition that the given vector field r power n r cap is solenoidal. So, in the part 2 of this present problem, let us assume that the given vector field r power n r cap is solenoidal. That means its divergence is 0. So let us equate the divergence of r power n r cap to 0. Div r power n r cap equals 0 implies the left hand side must be substituted with the divergence of r power n r cap, which is nothing but n plus 3 times r power n. So, this equation divergence of r power n r cap equals 0 gives us n plus 3 times r power n equals 0. But our one more assumption is r must not be 0. So, from n plus 3 times r power n equals 0, n plus 3 must be 0. If n plus 3 is 0, n equals minus 3. So, our vector field r power n r cap becomes solenoidal provided n equals minus 3. In r power n r cap, if we substitute n equals minus 3, this vector field becomes r power minus 3 r cap, that again equals r cap by r cube, which we have proved a solenoidal vector field in our previous problem. So we are done. Problem number 9. In this problem, a scalar field is given to us. First, we have to find out its gradient. After that, we have to find out the divergence of the gradient of the given scalar field. Let us suppose that the given scalar field is phi of x comma y comma z equals x cube plus y cube plus z cube minus 3xyz. First, we have to find out the gradient of this phi, that is the del phi. If we find out the del phi equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. For this purpose, we have to find out the partial derivatives dou phi by dou x, dou phi by dou y and dou phi by dou z. Here, in this problem, dou phi by dou x equals 3x square minus 3yz. Dou phi by dou y equals 3y square minus 3xz. dou phi by dou z equals 3z square minus 3xy. If we write down del phi now, del phi equals I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z, which in turn equals I cap times 3x square minus 3yz plus j cap times 3y square minus 3xz plus k cap times 3z square minus 3xy. This del phi is a vector field. To this vector field, we have to find out the divergence now. That means we need to find out div of grad phi. We have seen this before. Div of grad phi equals del dot of del phi, which again equals del square phi. So here we can do this problem in two ways. Number one, we can find out the divergence of our grad phi. That means we can find out del dot of I cap dou phi by dou x plus j cap dou phi by dou y plus k cap dou phi by dou z. In the second method, we can directly find out div of grad phi equals del square phi. That means the Laplace operator applied on phi, which is equal to dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square. In whatever way we find out this value, we get the same. If we find out dou phi by dou x, we get 3x square minus 3yz. If we find out dou square phi by dou x square, we get 6x. Dou phi by dou y equals 3y square minus 3xz. Then dou square phi by dou y square becomes 6y. Similarly, dou square phi by dou z square becomes 6z. Now, our divergence of grad phi, which is the del square phi, is del square phi equals dou square phi by dou x square plus dou square phi by dou y square plus dou square phi by dou z square, which equals 6x plus 6y plus 6z. This is nothing but 6 times of x plus y plus z. This completes the problem.
I hope you are enjoying our lectures. If you prefer any specific topic, please let me know in the comment box. You can write a mail to us for our lecture notes. Please subscribe our channel and press the bell for notifications. If you like the content, spread the word. Thanks for watching.